Okay, I wanted to do an example. This example is on page 163, I think, in your textbook. Yeah, 163, number 15. And wanted to go through a problem. I'm going to enter the data in the calculator. You'll want to get the I already have mine entered, but you'll want to get your calculator out and do that. So this question says, does how long children remain at the lunch table help predict how much they eat? The table gives data on 20 toddlers observed over several months at a nursery school. Time is the average number of minutes a child spent at the table when lunch was served. Calories is the average number of calories the child consumed during lunch, calculated from careful observation of what the child ate each day. So we're taking a look at that. Now I want you to notice something before you enter it into your calculator. And it wouldn't really matter, but notice that they put calories first and then time. So you might look at that and think, oh, well, this is the X value and this is the Y value. But look down here. Time is my explanatory and calories is the response. So if you want to, you could put, I'm going to put this in L1 and this in L2, and that's what I did. I didn't name anything for calories and time. I don't necessarily do that on just, regular homework problems. So if you go Stat and Edit and go to L1, remember to enter the data. So you're going to go to L1 and just put in, oh, I said that backwards. Okay, rewind. Well, you don't really rewind. This was L1, this was L2. So these are my values that are going to be my explanatory. Now, it really wouldn't matter because I would just, when I set up my calculator, I could have just switched the L1 and L2. So, but since I'm pointing it out, so in L1, I put all of the times. And again, those are in minutes. And in L2, I put all of the calories. So you should pause the video and put these into your calculator so that you can practice the process, okay? All right, so we're gonna, let's reproduce this graph. So if I go, I'm gonna make sure I don't have anything in my y equals, so I'm gonna get rid of that. Go second and then the stat plot, choose a plot, turn that on, and I'm going to, and my data is in L1 and L2. Now you might have pulse and exam, or whatever it was, anxiety and exam. So if you need to put in L1, you're going to go, if you had something else there, just go to where you're on top of that and then go second, and then notice the number 1 key is L1. And then you could do the same thing for the L2 second, and then the number 2 key has L2. So then once you do all that, if you go zoom and number 9 for zoom stat, and you end up with a graph that looks something like this. Now, I have my axes on. Since there's nothing on the axes, it's not that big of a deal, so I'm not going to worry about it. But you can kind of tell that we have our graph. All right, so that's good. Now, as far as what the questions are, here's the questions we're asked to answer. Find the correlation for these data. So we're going to go ahead and look at that. Actually, I'm going to take a picture of that. Whoops, didn't mean to do that. So I have a picture of that. Okay, so going on here then, to do the correlation, so I'm going to quit my graph, and to remember to find that, we're going to go Stat, Calc, and you want to go to number 8. So you can actually just type in number 8, linear regression, a plus bx. Your x list is L1, your y list is L2, and you're going to go down here to calculate. And what we're looking for on this, it's going to make that picture noise again. So what we're looking for from this is the value of R. So we want this right here. So that was the value that we're looking for. So we get that R, so I'm on part A, R equals negative 0.649. Now let me just show real quick, because I think we had somebody absent when we went over this. If you don't get the R squared and the R when you do the problem, then if you hit second, and then the 0 key to access the catalog. Hit D, which is the x to the minus 1 key. Scroll down till you get to something that says diagnostic on. This one right here, choose it, hit enter, it will say done. Now go back to that linear regression that I did, and you'll see those values. And you'll see the value of R. Okay, well, let's clear that. Okay, so moving on here. So now we have the value of R, and we are told, so that's the correlation. So part B says, suppose we were to record time at the table in hours rather than minutes. How would the correlation change? So what if we took all of our data, and so if we went back to this data and we wanted to change the time to hours, then we would divide by 60. And how would the correlation change? Well, this was the page you were supposed to read. And so hopefully you did, but I put it here on this video so you could pause it and read through. And one of the things that's important to notice is correlation has no units. So when you change, so it's not affected by changing the units. So it would be the same. So for part B, how would the correlation change? It would stay the same. And actually, does it have, if you go through and look at all these things, correlation is not affected by changes in the center or scale of either variable, and that's really what we would be doing. We would be changing the scale. Changing the units or baseline of either variable has no effect on the correlation coefficient. So, so it would stay the same. Changing units doesn't change the correlation. Okay, so part C. Write a sentence or two explaining what this correlation means for these data. Remember to write about food consumption by toddlers rather than about correlation coefficients. So when you write this, we know, what do we know about it? Well, we need to say how strong it is. We need to talk about the direction, form, and strength. So if we look at our graph, we can see that it has a negative direction. We know that two ways. We can look at the graph, but we also can look at the value of R, and we can see that it has a negative sign, which tells me it's negative. So there's a negative association. Then we have this 0.649. So how strong is that? If you remember in class, I gave you this little number line guideline. So we are in the moderate range down here, but it's still moderate. So we have a moderate, that's the strength, is moderate. So we've got and it appears somewhat linear. You can tell, you can kind of see a linear pattern. It would kind of, you can see that if I were to draw a line, it has a lot of scatter. So then we have to put that together and come up with a sentence. So we can say something like this: there is a moderate negative linear association between, remember we have to put our context in there, so let's look back at what this was, between the time children spend at the table and the calories they consume. So between time I could have said toddlers. I probably should have. Children spend at the table and the calories consumed. Okay? So if you think about what that means that the longer the time they sit there, the less calories they're consuming. So then our next question says, one analyst concluded, it is clear from this correlation that toddlers who spend more time at the table eat less, right? We see that. Evidently, something about being at the table causes them to lose their appetites. Explain why this explanation is not an appropriate conclusion from what we know about the data. And this is where you would say association does not imply causation. Maybe there is some other reason why the child is not eating the food. Maybe they don't like the food. So maybe they would rather sit there all day long than eat what that food is. So there could be other variables going on that we don't know about. And so we can't say that just because we notice an association, we can't say that there is a causation. So hopefully that helps by giving you another example, as well as giving you these so that you can look at in case you don't have your textbook at home. So then you'll have an assignment, and hopefully this problem will help you to do that.